Hello everyone. In the previous video, we covered message queues and the pub/sub model. This video is a continuation of that in which we'll be talking more about things that are specific to Kafka. So I highly recommend go check that video out first because a lot of those concepts are going to be used here and I will not be repeating all those details. So go check it out and then come back here. This video is not going anywhere. So without further delay, for those people who have watched that video, imagine a system like YouTube where a user can watch a video. Now, whenever a user watches a video, a lot of things are done with that data. So let's say you're a loyal subscriber, you watched the entire duration of this video. YouTube wants to recommend more of my videos to you because of that. It might want to send notifications of my videos to you. It may even want to show my ads or do some basic analytics at their own level for their own purposes. Right, so this watch time data, it has a lot of use cases. So what ends up happening is that there's an API call made to the video service. It can store this data. Question is, how do all these other services use this particular piece of information? Does the video service send all of this data to each of the services? First, it makes an API call to recommendation service, then to the notification service, then to the ad service, then the analytics service. It seems like a lot of work for just one piece of data. And if we had some other service in the future, we will have to not only add its implementation here, we will also have to add the changes to video service so that it sends data here as well. But we do not want that. It is not a very sustainable way of doing things. Question is, how do we actually go about it then? The answer is a centralized node or a server like Kafka. Now, when I say a centralized node or a server, the kind of node I am talking about was again talked about in the message queues video, because that is what essentially Kafka is. Right? It follows the pub/sub model. So we can start by understanding Kafka by its very first step, that is brokers. So brokers are basically these servers where your Kafka data is managed. And these are my brokers. That's the first component. Let's just draw that here. Then the next component is, and you will be familiar with this by now, producers. These are responsible for sending data to my broker. So whatever ends up happening, my producer, which is a Kafka client, it sends data to my Kafka broker. So this will be implemented at video service. This will be independent. So question is, when I'm implementing my producer, what exactly do I specify over there? Because just my raw data is not sufficient. It has to be categorized in a certain way because one server can have different kinds of data. It could possibly have, let's say, my user updated a profile. I want to process notifications for subscriptions to users. That is, if you, let's say, press a bell icon, I want to handle that separately. That will be stored in a separate category. Then there could be a third category, a fourth category. Basically, different use cases could be used on the same broker. So that is defined by something called topics. So topics define the kind of data you want to put on that particular server. So a server can have multiple topics in it, and that's really not an issue. But topics are usually defined by use case. So if you want a notification system, you can have a separate topic for that. If you want analytics data to be processed separately, you can have a separate topic for that. If you want to store comments separately, you can have a separate topic for that. All right, so this depends on the use case that you are trying to implement. And each of these topics will have the structure of a queue. So one for notification, one for analytics, one for comments. Each of them have their separate data, but this is not shared by them. Each one has a separate queue of their own, and their data is managed independently of each other. So that is how brokers and topics work. Next is, what do I do if I want to use this data? If I'm the recommendation service, if I want some watch time metrics, let's say my video service has pushed it to my watch time queue, how does the recommendation service or the analytics service get this data. So that is where the concept of consumers come in. That's the next component. Brokers, producers, and consumers. So I could implement a consumer using my Kafka client library, and that will simply subscribe to this particular topic. This is my topic. My consumer will subscribe to it using my broker. So basically, on this service, I will say that okay, go to this broker. On this broker, there is a watch time topic. Subscribe to it. Whenever there is new data on this topic, you say get it back to me. That is how consumers work. We've already discussed this. So this is how this particular implementation is coming into play. So think about it like a shopping mall, a very new age shopping mall, where you could purchase things at any shop in the mall, but the payment has to be made at exactly one place in one particular section of the mall, not at each individual shop. That is how you can understand Kafka. So my video service sends some data over here, and all of these services can have their own consumers subscribe to my watch time topic, and whenever there is some new entry to my queue, let's say it's here video data 1, and this will then go to each of them. All right, so that is how the flow works between producers, brokers, and consumers. And they can do with it whatever they want to do. This can add more videos, this can send notifications, however it may be. If there is an ad service, you can generate invoices based on that. So different use cases for different companies. Now, an important question is, how do we know that on our queue, if there are different services trying to consume data, how do we differentiate between them? Because we want V1, V2, V3 to go to all of these at least once, right? All of them deserve to have all of the messages in this particular queue. So how do we go about identifying which service is requesting this data? That is where the concept of consumer groups comes in. So whenever you're defining a consumer, you also specify the consumer group that it belongs to. So for example, if you're part of the video service team, you will say that this is my group video service followed by your environment, let's say production, something like that. If you're part of the analytics team, you would do something like analytics. Then Kafka would know that if V1 has gone to my video service consumer group, I can just send V2 next time. I don't have to send V1 again. Similarly, I can differentiate. If analytics service is just coming up, it has just gone live, I will send it messages from V1 because I know that this is a different consumer group now. So that is how Kafka differentiates between different sets of consumers. So the next thing I want to cover is this streams library, because we've been talking about some use cases of message queues and pub sub models so far, which are asynchronous processing, so that we can delegate some workload from the main processes to this queue and it can happen in the background. But Kafka can also be used to solve a lot of real-time use cases, like it could be used in real-time analytics. One good example of that would be an app like Uber or Google Maps, where anytime there is an update to a driver's location or your location, it could be sent to Kafka and then propagated to whoever it needs to be sent to, whether that is the analytics service or some security service that they may have, or the customer themselves. So this is one use case for that. Another is fraud detection, because this needs to happen in real time. So let's say when you're using a credit card, banking systems could use this. You make a purchase which is not fitting the pattern of your usual purchases. So this would detect, basically the data would be sent to Kafka, it would be sent through the processor in real time, and then you may receive a call from your bank saying that, okay, did you really make this purchase? Because it is seeming to be a little unlikely. Is your card stolen? So they use fraud detection for that. They may block purchases using this. It's just an added security feature. So Kafka can be used for that particular use case as well. Then the streams library also provides us with a high level abstraction. So it allows a lot of operations like aggregations, summing, and other things like that. For example, I, as a YouTuber, may want to see data on my YouTube studio for, let's say, the number of views from USA, number of views from India, from any other country. So Kafka, Streams library in specific, can be used to process this data in real time and have it display on my YouTube studio as well. So inbuilt, it can help me perform these aggregations without doing a lot of legwork as a developer myself. So that's one thing that can be done. Or if I want to, let's say, analyze comments on YouTube to discover some trending patterns, that can also happen using this streams library. So this is a good implementation that I highly recommend you study, especially on your own time. Go deep into it, it will be very useful. So you should do that. Next thing I want to talk about is how to scale Kafka. Because Kafka is pretty scalable in itself, but one particular example that I can give you is that once I was building a notification system, and what ended up happening was that while it was working fine, the process was running in the background. The only issue was that it was taking a lot of time, about 2.5 to 3 hours, to finish one batch of data. And it was a lot of data, to be fair, but 2.5 to 3 hours for notifications is a lot, especially if you want some near real-time effect. So to scale Kafka, there is a concept called partitions. Partitions help us in dividing our workload. How do they do that? Let's say there are 1000 messages that are to be processed. Messages are simply data sent from producer to a topic. Now, 1000 messages will either be consumed one by each consumer, and that could take its own sweet time. But partitions, what do they allow us? They allow us to scale horizontally. So it says that how about you split your data into, let's say, four partitions, that is 250, 250, something like this. And let's say if you have four servers available in the same application, let's say in my analytics service, I have four different pods available, horizontally scaled. If you don't know what horizontal scaling means, go check out video 1 in this playlist. Horizontally scaled, and what that would allow me to do is that use all of them to their full potential. So what that would do is it will assign one partition, let's say this partition 1, 2, 3, and 4. It will assign one partition each to each of my servers of that particular service. So this particular partition P1, so this particular server S1 will receive data from partition 1, S2 will receive it from partition 2, so on and so forth. So now my data is split into four parts, and that helps me reduce my processing time by a lot. In fact, in the example that I was trying to give before, in which it took me 2.5 to 3 hours to complete the entire processing, when I involved three partitions into the process, it reduced it to just 10 to 20 minutes each time consistently. So it has a significant effect if used properly. A couple of things worth talking about when we talk about Kafka is its ability to enable replays. So let's say you consume data from a particular topic, you process it, somehow it gets erased for any reason or didn't get processed properly due to some bug. Kafka allows you to replay the entire thing from the first message or till wherever data is available back to the latest data so that you can have your processing to be as intact as possible. So that's a very good feature that Kafka does give us out of the box. And it can also store messages for long term if you wanted to. Usually people do not keep it that persistent. They consume it, they prefer to remove it after, let's say, 1 day, 2 day, 3 days. But if you want long-term persistence, Kafka gives you the opportunity to do so. So you can do that while implementing other concepts which we studied in the fault tolerance video. If you haven't seen it, go check it out. And that's all I want to talk about when it comes to Kafka. You can let me know what you use it for in your own projects, and I would love to see it in the comments down below. In the next video, we'll cover another cool system design concept, so stay tuned and follow for more.